For this next examples, we're going to look at the distance between two parallel lines. If we look at this sculpture, there's a parallel line here and there's another parallel line here. So if we find the slope of PR, we can find the perpendicular slope for SR. And in this case, we don't really need to. They're just showing you how you would find the slopes. So we're just going to find SR, and I'll breeze through the first part quickly. Looking at this, it says we need to find the length of a perpendicular segment because the shortest distance between either two parallel lines or a point and a line is the perpendicular distance. So they found the slope of PR, and the perpendicular slope would be a -2/3 in this case. And in this case we didn't need to do it, but in the next one we will have to do it. So you use the distance formula to find the distance between the points using S and R. I believe S was 35, 120 and R was 50, 110. So you plug everything in there, you get your answer of 18.0 inches approximately. For this next one, we want to find the distance between point A and line C. So this is how we do it. First thing we do is, I'm going to zoom in a little bit. We're going to take a look at this. So what we want to do, ooh, that's too close. Let's try that again. Okay. So we want to find the distance from this point to this line. And remember, it has to be a perpendicular distance. So if you notice, there's a point here, and they give us this point, but I kind of like this one a little bit more, or this one down here. Those are all points that are on the line that are easy to read. So I'm going to use this 0, 2, and I'm going to use this -1, 0, and I'm going to find the slope. So the slope in this case would be 2 minus 0 and 0 minus a -1. That gives me a slope of 2/1 or 2. And so if I'm going to do the slope here, let me go ahead and move this out of the way. -1, 0. We're going to go down 1 and over 2. That puts us right about there. And then we can draw our perpendicular line. So we're going to go something like this. And that point right there, we're going to have to guesstimate. Most of the time for the examples I'll give you, you won't have to guesstimate. But you'll have to show me this work. Because the line here that's perpendicular will be -1 over 2 because it's the opposite reciprocal. So that's why I went down 1 and over 2. And that gives us this point, which looks like it's about -1.7, 1.9. So I'm going to use that to find the distance. So the distance in this case would be, let's see, the square root of, coordinates here are -1, 2, 3, 2, -3, 2. So we would do -3 minus a -1.7 squared plus 2 minus 1.9 squared. And if we do that, I'm going to have to get out my calculator. Let's see. So that gives me approximately 1.3, -1.3 squared plus 0.1 squared. Oops, sorry. I gotta scooch up now. Okay. And then 1.3 squared is 1.69. plus 0.1 squared is 0.001. 0.01. So we get the square root of 1.7, which is approximately, give me a sec, rounding it, approximately 1.3. And so that's the first part of this. For the second part of this, we need to find the distance between lines C and D. So again, we're going to use the idea of the slope, and I'm going to zoom in real quick. I'm going to have to zoom out first, and then re-zoom in. Okay, so we've got, let's use this point right here again. We've got this point, and if we go down 1 and over 2, we're going to end up there. If I draw the line that's perpendicular here, it's going to look something like that. And that point right there, let's see, this point is -1, 0. And this point looks like 1.6, 1.8, 1.9, something like that. Let's go a little bit less. No, let's do 1.9. Okay. So it should be pretty close to what is the actual answers. We're going to use the distance formula again. And we have -1 minus 1.6 squared plus 0 minus 1.9 squared. Oops, and that's 0.9, sorry. That should be 0.9 and negative. So that makes that plus. And if we do that, we get -2.6 squared plus 0.9 squared. Oops, I knew that was going to happen. So I'll just move back up. And for 2.6 squared, we get 6.76, and for 0.9 squared we get 0.81. Together we get 7.57, and if we do the square root of 7.57, oh, this is off what they have, but it's okay. About 2.8. So you got to be careful when you draw these. As long as you're pretty close, I'm happy with it. And again, the ones that we'll do, I'll give you, it'll actually match up with an actual point. So for this last one, it says to graph x plus 1 and then find the distance between, find the point on the line that is the shortest distance from 4, 1, and what is the distance. So I'm going to need a graph for this. So let's get that out. Give me one sec. Okay, so give me a sec to find this real quick. Let's see. Nope, it's not there. I know it's here. Let's do this one. Oh, okay. Sorry about the wait there. I'm going to zoom it out one more time. Okay. So the line was going back was x plus 1, and the point is 4, 1. So we've got y equals x plus 1, and the point 4, 1. So we're going to go 4, 1, and then we're going to do, this has a slope of 1, or 1 over 1, a y-intercept of 1 as well. So we start with the y-intercept and we go up 1. From there, we go up 1 over 1, up 1 over 1, and we draw our line. So the line looks like that. We know the slope of this line is 1, so the perpendicular slope is the opposite reciprocal, which is -1. So from there, I can go down 1 over 1, down 1 over 1, or I can go up 1 over 1, up 1 over 1. And there is the point. Let me see, the original point was 4, 1. And so our line that is perpendicular will be this line right here. So what we want to do now is find the distance between 4, 1 and this point here. That is the shortest distance between the 2 points. This point is 2, 3. And I want to go ahead and find the distance. For the distance, we're going to say 4 minus 2 squared plus 1 minus 3 squared. So in this case, it's 2 squared plus a -2 squared. This gives me square root of 4 plus 4. Moving it down, we've got square root of 8, which is also 2 rad 2. And punching this in on my calculator, give me 1 sec, I should know this. The answer is approximately 2.8. So there you go. And we're all set. Thanks.